Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about recommendation ranking. This episode is based on a tech blog titled Evolving Feed Ranking at Whatnot, written by their engineering team. You can find the blog link in this episode's description. Throughout this episode, we will explore this topic from both the business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Whatnot is a fast-growing live stream shopping platform that combines entertainment and e-commerce. In 2024 alone, this company surpassed $3 billion in gross merchandise value. Every week, buyers and sellers host more than 100,000 hours of live stream shows across more than 100 product categories and in 9 different countries. The core advantage of Whatnot's business is discovery, connecting buyers with the sellers, products, and shows that they love. In fact, about 65% of Whatnot's overall sales come from the feeds, and about half of those sales come directly from the personalized For Your feed. That means feed ranking is central to the company's success. The better such ranking performance is to match what the user's true needs to interest, the more engaged and revenue it would generate for the company's success. Now that we've understood the business problem, let's dive into the technical side to see how Whatnot tackled the feed ranking challenge. The first version of the team's machine learning-based ranking system relied on offline predictions generated in daily batches. Each day, the team calculated watch and purchase likelihood for all possible pairs of buyers and sellers in the system. These predictions were stored and later used to rank shows whenever a user opened their feed. This approach had advantages, mainly on the simplicity and easier error handling. But as the platform grew, several limitations became unavoidable. First, there was the scaling issue. With millions of buyers and sellers, generating predictions for every possible pair became computationally explosive, and most predictions were not even useful since not all sellers are active at the same time. Second, the system lacked real-time context. For instance, if a seller started streaming sneakers and switched to Crocs 5 minutes later, the batch predictions wouldn't capture that change. Third, the system faced the cold start problem. New buyers and sellers had to wait at least 1 day before predictions became available. Finally, batch predictions went stale so quickly, so much could change in a fast-moving live stream marketplace between daily runs. To solve all these challenges, the team migrated from the batch inference to online inference, which is a major architectural shift. Instead of pre-computing predictions in bulk, the system now generates them at request time, when a user actually opens the app and needs their feed ranked. Here is how it worked. The pipeline still includes offline components. Event logs are processed daily to create training datasets, which combines historical features, request-level features, and user engagement labels. Models are trained offline, then deployed as endpoints capable of serving predictions in real time. Then here comes the online component. When a buyer opens their feed, the system identifies all current active shows and retrieves the relevant feature values, both historical and real-time values, from their feature store. These features include buyer behavior, seller attributes, and live show details such as different product category. The model then uses these features to generate predictions on the fly, ranking shows by their likelihood of driving watches or purchases. A key detail here is the use of the negative sampling during the model training time. Now, the model isn't trained only on positive interactions, like purchase or long watch time, but also on those non-events, such as shows that were surfaced to a buyer but get ignored. These hard negative cases help the model learn more effectively by distinguishing between shows a buyer sees but doesn't engage with versus those they truly find relevant. The shift to online inference brought significant improvements. The For You feed saw a 7% increase in gross merchandise value, a 5% increase in orders, and notable gains in engagement metrics like watch time, which is a substantial improvement at the marketplace scale. Of course, online inference also introduces new challenges as well. Latency became a concern since predictions now had to be generated in real time. This puts the pressure on serving infrastructure. Stability and scalability also became critical, as the machine learning platform had to scale dynamically with app usage patterns. And because the system relies on offline training with online inference, ensuring those feature consistencies across the two environments was another tricky but important challenge. Overall, the migration unlocked much greater flexibility, freshness, and scalability, ultimately leading to a significantly better user experience. Now, we've discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored how Whatnot evolved its feed ranking system from batch predictions to online inference to better handle growth and capture real-time marketplace dynamics. This shift highlights a broader trend in recommendation systems, moving toward more adaptive, real-time personalization. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.